labs, right? They should be relatively straightforward. What is the first thing I have to do? I don't know if we have to do that. I think so. With this, you just want to you can assume everything is set up.
It wouldn't have given direction tell.
Well, then why does it give us all like the data registry direction, like all that?
You may use. Right?
Oh,
I could give you like a whole sheet of things and tell you.
well, I mean, like if we're doing like 4B, like it gives us everything for port B. So I mean, like yeah, I'm guessing is it like we skip all the initiation and initialization.
Well, what you can do, right, is you can say assuming like previous initialization, right?
Is that gonna go over okay? Like,
What? I thought this question's about initialization.
Yeah,
it is.
It's initializing 7.
Right, but it says write assembly code that makes PV7 an output and PVO an input, right? So this is ambiguous, right?
You need to initialize them to be output.
Do you really want to do more work, or do you want to tell the professor that I was right? So if you want to get a good grade, you either write your assumptions, right, or you go through the whole process, right? So plus you should know the whole process anyway. So let's go over that. Right. So what is the first thing I have to do? So in assembly code, I would have to do an LDR, right? R0 or any register for that matter equals sysctl underscore rcgc2 underscore r, right? So what does that do? That gives R0 the address, right? And then I'm going to load the value, or then I'm going to store into R0. Wait, what? No, I have to load. I need to load R1 with sysctl rcgc2 gpiob, right? And then I can store R1. Right? What does this do? If I were to put a comment here, I would say sets the clock for port B. Does that make sense?
Aren't you supposed to modify the context of
The contents?
it? Like make it a 1 or something?
you did though, because like the second one, that thing you
Okay, because for the clock, for the gating of the clocks, like this is non-safe. So what? I guess what I could do is I would do that would be more correct. You're right. I just tend to ignore it because it says if we're initializing just port B, we can generally just write out a 4 into it. 4-0.
Isn't the sysctl GPIOB like a mask to push on to initialize port B?
Yeah, so you remember the syscontrol register looks something like this, where you have your 8 bits, and this is like port A, port B, so on and so forth. Right? So if I only want to set port B, I just enable that to 1, and the rest would just be zeros anyways. That's what I was assuming. But you're right. If I want to do safe assignments, which it doesn't say I'm. So the way I'm approaching this problem is that when someone gives you a problem and you're trying to finish the test as fast as possible, you do it to the letter of the word because you can get your points back for sure. Right? So if he says use safe assignments, use safe assignments. If not, you can ask, like you can raise your hand and ask, do I have to use safe assignments? And the answer should be probably, but you can usually get away with not using safe assignments if someone tells you not to. You don't have to. But you're right, this is the safest way to do it. Okay, so then I've initialized my clock, right? If I want to make it an input or output, now what do? So now I do my direction, right? So I do that whole LDR thing, R0, I'm just going to put DIR. Everyone understands what that means, right? I'm just loading that whole thing. I don't want to write the whole thing out.
Yeah.
Yeah.
I just have a quick question. Are you ignoring the addresses of the two so you have actual values stored in those locations.
Oh, so then I would have that
Yeah, alright, gotcha.
R1 here. I don't know. So let me go over this again. You're right. I'm sorry. So then I want an LDR R1, R0, and then I want an LDR R2. Equals sys CTL, blah blah blah, you get it in GPIOB. And then I'm going to have an OR, R2, R1, R2. Okay, so that would be right. So both of you guys are right. Sorry. All right. And then my next thing is going to be data direction. So LDR, R0. I'm just going to put DIR, but you know which definition it is, right? So I'm going to have LDR, R1, R0. Okay? Yes.
So if it doesn't tell you what registers you can use any of them,
Yes.
and like, what if they say run a subroutine? Like I remember, like in Zero, if you have like save the values, you know, they don't care.
If they don't tell you to save them, it doesn't matter.
So if they tell you like the input is R1 and then like the output is R0, can you use actually run save?
Yeah. If they don't tell you, like if it doesn't say like if it says save all registers that you modify, right? Then save all of them. If it doesn't, assume you can use whatever registers.
How do you save them?
Push and pop. So you would push the registers you used, just like an LC3, right? You would just push like R whatever, blah blah blah, in the list, and then at the end you would pop. Okay. So we load this value. If I want to set PB7 and PB3 as outputs, what do I do? What's my mask? Hex 8. What?
8. 8.
Yes, 8. Right. So then I'm going to. I want them to be outputs, right? So I'm going to OR R1, right, with 8. Is that correct? And then I'm going to store back. Oh wait, no. I have to make PB0 input. Right? So then I'm going to do a bit clear. R1, R1. And then I'm going to store back. Okay. So that's for the first answer. And then I guess I would also have to do the alternate select, right? So if I want to do alternate select, right, do I have to keep going for this, or does everyone kind of get it? Because this is just your lab code, right?
I don't understand why we need to write clock or alternate select when it's just asking for the input.
Just, I mean, you don't have to, I don't think. If it just asks you for direction, I would just do the second part. But does everyone sort of get it? To be, I mean, if you didn't want to raise your hand and ask someone what you had to write, you would just write everything out. This is just study your labs, right? It should be pretty, yeah.
For AF select and data enable, we just use x88 as another constant.
AF select, you're going to use not x88, right? Or you're going to bit clear x88.
Like we want all the alternate functions to be set off, right?
Well, actually, if you want to set, so if I want to do alternate function, right? So let's say I want to set the alternate functions off. To be safe, the safest way to do this is to do my LDR, R0, AFSL, right? LDR, R1, R0, and then I'm going to, it's 0, right? 0 disables alternate function. I'm going to bit clear, not mask 88, but actually mask 8, 9, right? Right? Because I want PE 7, 3, and 0, the alternate selects for each of those to be disabled, right?
But it won't affect the other bits.
Yeah, generally you don't want to affect other bits.
You don't even turn it on the other
Would be
bits.
okay.
But for this, I think for the purpose of this test, if you did like a move 0 into R1, it would be okay. Especially with the wording of this particular problem, right? Some of the professors will definitely write use safe assignments, and using safe assignments would be this. If not, you could just go move 0 in, right? That would be easy. Any more questions about that part? And then, so the next question is write assembly code that clears PB7 and sets PB3. Oh, well, let's see. So the next part is write assembly code that clears PB7, sets PB3, PB0s, or PB00 and sets PB7, and do the opposite if not. So the way I wrote this was LDR R0 equals GPIO or B, you get it, data. Right? And S, R1. Okay, so that's what I did.
What's that third instruction?
The third instruction, this one, BICEQ.
What's the
This one, oh, and S. It's an and S. So it's an and that sets condition codes. Right, so what I'm doing here is instead of using looping or like a branch statement, I'm saying, okay, this and sets the condition codes, right? So it's only looking at PB0 as the input, right? So if PB0 is, okay, so if PB0 is 1, right? Since it'll be in here. If PB0 is 1, what happens? I execute this instruction, and I execute this instruction, right? Wait a second. Did I do that right? Yeah. So in this one, I'm clearing. Oh, in this one, I'm clearing PB3, and I'm setting PB1 or PB7, right? If the opposite is true, I'll execute these two instructions. Right? So you guys should know this by now. Okay, so whenever I have an instruction, right, if I have any opcode, I can append conditional operators, right? This is in that chapter in your book. I can append conditional operators, and that instruction will execute or not execute based on the condition code flags, right? So so this works sort of the same way as like a branch, right? Instead of the branch instruction is basically a branch with these appended. So this is saying that execute this instruction if the equal condition is valid. Do you see that? And you can do that for basically any instruction in the whole instruction set, which can make your code a lot simpler. So instead of having to branch to perform one instruction, you can just have that one instruction EQ. right? Or NE, or LO, or GT. Yeah.
So those don't have to go in order, right?
No. Alternatively, I mean, right, I could do the same thing where instead, when I get to this point, I could do, you know, a BEQ, right? And I could have my set of instructions that would be like next, and I can have a BIC R1 BEQ. BIC R1 X0. Alternatively, I could do something like that, right? These are like equivalent. Okay? Does that make sense? There are many, many ways to answer this problem. If you have been doing your labs, this should be pretty easy, pretty simple. Does anyone have any questions about this? No? All right, cool.